Okay, so today I'm going to talk to you a little bit about some of the work that we've been doing and some of the work that's been going on in other labs, talking about how we can maybe improve face recognition in prosopagnosia. I should say before I start, rehabilitation or interventions can be quite a contentious issue, and I don't want any of this to come across in any way as prescriptive. We don't really have many answers in terms of interventions just yet. This is just to give you a bit of an idea of the shape of the research and where we'd like to go from here. So before I start getting into the programs that we've been doing, there are a couple of different approaches that we can take to intervention. The first one is much more compensatory. So it's trying to figure out what people are good at, despite or maybe because of the prosopagnosia, and working with those cues to make recognition better by focusing on things that maybe other people don't use so much. The second option, remedial or restorative, depending on which vocabulary you like, in this case, we try and identify what seems to be the problem in prosopagnosia, and then we try to train those skills. So we try to restore people back to what we would consider to be normal styles of face processing. It's not easy intervention, and there's a couple of reasons for that. First, as has been suggested by a couple of the speakers today, our theoretical knowledge of what's going on in prosopagnosia is still, it's in its early stages. We've only been researching DP for a couple of decades, but it's very important to understand what the difficulties are in order to target either the skills that are still available to you, or to try and target the things that are impaired. The second difficulty is that every case is ever so slightly different. The majority of work in this field has been done using case studies, so it's really difficult to know in some cases what factors are important and what factors are simply an aspect of the individual person. So it could be things like age. A lot of the studies have been done in kids, or it could be that certain people have different strengths. Some people actually have quite good face perception abilities, but quite poor memory. Other people are the opposite. The other thing, of course, is that we need to try and find interventions that balance the benefits that you get out of them, and I should say at the outset that most of these are quite modest benefits, against the time and the effort that people have to put into them. There's no point in telling you to sit down for 2 hours every day if it's only going to help you recognise maybe one extra person a week. So having said that, just so we understand what we're talking about today, a tiny bit of theory. A lot of the research in prosopagnosia has found that people tend to be not so impaired or relatively okay at picking out featural differences between faces. So I suspect a lot of people in the audience, maybe not everyone, can see that along the top row here, the eyes in the face are different in each of the faces. On the other hand, people with prosopagnosia tend to have a bit more difficulty picking out differences in spatial relationships. So this can be a very difficult task for them. So these faces down the bottom only vary in how the eyes are spaced sideways or up and down. There's also evidence that people with prosopagnosia have difficulty integrating information from across the face. So most people find this task a lot easier if we're trying to pick which is the same face and which is different. Most people with normal face recognition ability find it easier if they're in the whole face compared to if the individual features are isolated. That's generally not the case in prosopagnosia, or they show a weaker effect. So what that suggests is that they're not doing this compulsory integration of information from across the whole face, but rather they're doing a much more piecemeal, feature by feature kind of processing strategy. And that could be because, or this could be because of, people with prosopagnosia tend to look at different areas of the face. So this is a very old paper from a different lab showing that people with prosopagnosia tend to focus much more around the outside of the face rather than looking at those diagnostic inner features. And this is some data from our own lab from an acquired prosopagnosic, and you can see here that she loves hair. that's a great thing for her, whereas people without prosopagnosia tend to look very much at the eyes, nose and mouth, which are quite diagnostic for identity. So, taking that in mind, the first types of training strategies that I'll talk about today are featural kind of training strategies. That's where they take a face like this. This is my lovely little nephew Hayden. And they say, okay, let's pull out the individual features. We know that people with prosopagnosia don't tend to be so impaired at that. So let's look at the fact that he's got a particular shape of face, his nose is a bit turned up compared to his brother's, I'll show you later, and he's got quite wide brown eyes. And so processing the features like that individually can sometimes help face recognition. There have been a couple of studies that have looked at this, several from other labs and one from our own. But they've all been single case studies and they've all used kids. Should say I'm just focusing on the developmental cases today. There are a couple more studies with acquired cases, but I could stand here and talk all day if I was going to do that. The training in this kind of strategy is fairly light. So most of the kids have only gone about 25 minutes per session and only a few sessions, and always uses familiar faces, so faces that they see in everyday life. And what we've found, or what the studies have found across everything, is that once people have completed this training task, they get to be very good at recognising those trained images. Very, very good, generally 100%. And this tends to generalise quite well to other images of the same face. So if you show that same person from a slightly different perspective, or you put a different haircut on them or something like that, people are still quite good at identifying them, which is quite nice because that's a bit more of a real-world task than sitting down and trying to identify the same image of a person each time. Unfortunately, there doesn't seem to be a lot of generalisation to other faces. So people don't seem to be taking this strategy and using it in their everyday life. And there's minimal generalisation to real life. One of the cases reported that the child who underwent the training was a little bit better at recognising some of her family members some of the time, but that's not really what we want out of training when it comes down to it. Also doesn't seem to help face learning, so again it suggests that people aren't spontaneously taking this strategy and using it in everyday life. But it does seem to help face matching. So what people seem to be doing is they're starting to focus on the right kind of cues, but it's not generalising very well. And we know that it's starting to focus on the right kind of cues because one of the studies did some eye tracking. Like I was showing you before, prior to the training, this young girl was all over the place. Again, particularly liked hair. After the training, she was much more focused on these internal features, the kind of things she'd been trained on. So some gains, some good things, but certainly not a cure-all. The other slight drawback is that while the recognition of familiar images does tend to continue for at least 4 to 6 weeks, the generalisation of images doesn't continue for that long. So while featural training can be good at teaching people how to recognise a particular photo, it might not be great at teaching them how to recognise a particular face. It's also extremely labour intensive, it takes a lot of preparation and you can't really feasibly do this with every face that you're going to encounter. And we really don't know how we're going to take this forward to get people to generalise it to new faces. We've got a couple of ideas, but nothing's been really that successful yet. The other question, of course, is that given this is all done in kids, we don't even know if it's going to be useful in the adult population. Many people, especially the ones who come into the lab, report that they use this kind of featural strategy in everyday life, so we don't know whether training them up on it is going to give any extra benefit on top of what they already do. Of course, featural training isn't the only compensatory strategy. Some people have used semantic encoding where they give people a lot of information, occupation and context and that kind of thing about a person when they're trying to learn a face. And that's been used quite successfully in several acquired cases of prosopagnosia. But it's not really appropriate for people who have perceptually based difficulties. And there's also some alternative information, like we've just done some research in our lab that's found that movement cues can be very, very useful for face recognition. Sorry, I get quiet. Back row, just wave, it's fine. So movement cues can be very helpful in prosopagnosia for getting people to recognise familiar faces. So one avenue that we're looking at taking the training is teaching people to focus on these movement cues rather than teaching them to focus on individual features in a face. So the restorative strategies, rather than focusing on these individual bits of the face or on unusual cues like movement or bodies is another promising avenue, so rather than focusing on these bits, they focus on these kind of things. They say, okay, can we try and make people better at taking out this spatial information or of integrating information across the whole face at once? One of the studies that has used this technique has just come out from Harvard. What they did is they taught people to classify faces into groups based on the spacing. Now, I imagine this is a very, very difficult task for a lot of members in the audience. Essentially, what they've done is they've said that these faces in group number 1 have very high eyebrows and low mouths. These faces in group number 2 have quite a high mouth and relatively low eyebrows. So they simply gave these faces to people and said, okay, classify them into group 1 or 2, do the best you can, really try and focus on that spatial information. And they tried to get them to do it as quickly as possible. So rather than making it this kind of laborious, let's look at the nose, let's look at the eyes, let's look at the contours, which can be slow and a bit awkward if you're doing it in real life situations. They're trying to make these people develop these snap judgments about spacing. They've done it twice. Once was a very, very intensive case study, and once, which just came out last week, was a large group study with 24 participants who underwent this training. It's very intensive training. Participants were doing up to 900 trials per day, so probably talking about at least an hour per day over a 2-week period. In the case study, it was even more than that, 4,000 trials per day, which is a lot. And over 2 weeks separated by a couple of months. Given the amount of effort that the participants had to go through, they did get quite decent results, which was, I guess, fortunate for them and their participants. People got a lot better at unfamiliar face matching, so they got a lot better at making those fine-grained discriminations very quickly. Unfortunately, that didn't generalise to different viewpoints of the face. This is a bit worrying, given that we don't tend to see people from a beautiful front-on perspective in everyday life. They did find some benefit for face learning, and they found some gains, not a whole lot, but some gains for face-specific types of processes, the types I was talking about earlier, where you're integrating information from across the entire face. So it suggests that this technique is working in some ways, it's improving the perceptual abilities. But the reason I've put the stars next to these two is that they found that it was really only effective for some of their participants. It was about 13 out of the 24. And it tended to be those people who were more severe when they began the testing. So this technique might be very promising for people who have quite a severe impairment, but it might not have such positive results for people who are at the milder end of the spectrum. We're still talking people with quite severe everyday life problems, but who don't perform so badly on lab tests. On a more promising note, they did find that people were reporting much better recognition in everyday life following the training, but that was mostly related to confidence. So people seemed to say that they were much more confident going into situations. They weren't necessarily reporting that they were recognising more faces, but they were much more confident. Now, I don't want to undersell this, because obviously confidence is a big thing, and that's something that you were talking about a little bit. You've got to be... we can't just focus on the measures, we have to focus on what you guys are feeling as well. But it's not the exact outcome they were hoping for, I feel. Okay, so obviously some limitations that I've already talked about. It's quite intensive, doesn't generalise very well, and we're not sure whether we can apply this kind of training to younger participants. So what we're doing in our lab is a very similar type of strategy, but we're trying to get around some of those difficulties. We're training people using morphed images. There's two things that I want to really highlight with this. First of all, we're training people on different viewpoints. So straight away, we're trying to get people to generalise between viewpoints. Second of all, These images are morphs. So these two images are, these aren't morphs, these are just 100% of identity. These two images have become significantly more like one another. And that's in both the features and the spacing. So the whole face is changing, and the aim is to try and get people to pick up those really, really subtle changes. This program is a little bit less intensive than the one coming out of Harvard because we're trying to get it to be self-paced. So people complete 40 of these training trials in a session, which, depending on how long they take, I think a lot of people take about 5 minutes to do that. If they get 36 out of those 40 correct, they move up to the next level. If not, they continue to do this same level until they get better. People can do as many sessions as they like in a particular day. So we've got some participants who do one and move on. We've got some people who sit there for an hour and move on. It's just a little bit more integrated into everyday life. Just so you know what it looks like right at the end, this is level 10. This is almost impossible even for super recognizers, but it does get people doing extremely difficult face recognition tasks. Does anyone want to have a stab at any of these ones? Just for fun. Okay, I know Bob doesn't want to do it. Anyone? No? Okay, that's fine. It does look a little bit better on the real screen. It's a little bit easier. So we've run this program. We did one very intensive training study where we got an acquired prosopagnosia in our lab, a teenager named EM, to do this training program over 13 weeks. She got up to level 8, which is amazing. It's a lot better than most people with normal face recognition abilities could do. And she did about 30 hours of training during that time, but it was entirely self-paced. Some days she did nothing, some days she did a couple of hours. She did it during school. We're also piloting this in some of the developmental prosopagnosics who have signed up through our online website. And we're also using this training with people with normal face recognition abilities to see just how far we can push it. I'm going to talk about EM today because the other results are still very, very, very preliminary, and I think they're going to change a lot. But with EM, this face training program, it didn't improve her face recognition on lab-based tests of face learning, but it significantly improved her face perception abilities. And unlike the other study, these were tests where you had to discriminate faces at different angles. So she got a lot better at that. She also got a lot better at recognising familiar faces. So we tested her before. She got 3 out of 16 familiar faces correct. She's quite a profound case. Afterwards, she was getting 9 or 10, and this maintained quite well 1 month and even 3 months later. She was still recognising those familiar faces quite well. There was also some generalisation to real life, but again, this was very much related to confidence. She felt a lot better after doing this training program, and she was more confident to walk up to people and say, "I think you're this person," which was very nice for her in school. I don't know if any of you have seen the documentary, which is about this particular teenager, but she was very, very introverted beforehand. We also tested her on eye tracking, and once again, we found that controls looking at this inner area, EM looking at the hair before training. After training, she was looking at pretty much normal areas of the face. Once again, this maintained for at least a month after the training program. So it does suggest that this particular morph training program, like the spacing training program, has some potential to improve face recognition, even in very severe cases. And I'm hoping that at some point soon we might have some data for developmental prosopagnosics as well. So from here, I'm just going to quickly give you a taster of maybe what you might see next year if we manage to come back. The next thing that we're trying to do is combine compensatory and featural training strategies. Oh, sorry, compensatory and restorative strategies. We're using this in kids, and we're creating that morph program with faces that are already familiar to them. So this keeps them nice and engaged, they're quite excited about it, and again, it's nice because it's quite short. We're only getting them to do about half an hour per session. But we are seeing some quite good results from the pilot study of this. Again, these are my little nephews. I put them on everything because they're beautiful. Down the bottom here, for most people, it's not too difficult a task. But once we get to here, they're very, very, very similar. And the child that we're working with has already gotten to this level. He's gotten to the point where he can discriminate his friends even when they've been morphed up to 85% with another face. So he's getting very, very good at those discriminations. And he's also reported some real life benefits as well. I'm hoping they stay. Okay, so one of the things that I've tried to emphasise, and I don't think I have because I've been going a million miles an hour, is that some of the training programs, they have promise, but we're not quite there yet. And some of that's because we don't have enough large group studies to try and figure out what actually matters, so whether things like age matter, whether things like severity matter. And part of that's because maybe we need extra. Maybe we need extra things on top of the training to give it a boost. So one of the things that we're looking into is the inhalation of oxytocin. Oxytocin is a hormone that is implicated in a lot of social cognition and in bonding. In typical participants, it's been found to improve face recognition, and as some of you might have seen last year with Sarah, there has been some benefit for people with developmental prosopagnosia as well. That's just been single session studies at the moment. The next step that we're doing is combining the training programs with inhalation of oxytocin to see if the oxytocin makes the training program stick a little bit better. So maybe we can give people training programs for a shorter period of time to get more long-term benefits. The other thing that we're investigating is transcranial electric stimulation. We're doing this in collaboration with our lovely people at Goldsmiths. Transcranial electric stimulation involves applying a very, very weak electric current to the head via electrodes. Don't make that face. It's a lot less, it's not that scary, I promise. It sounds a bit funny, but generally most people report at most a mild tingling sensation. And in single session studies, it's been found to improve cognition in a variety of situations, including some of the face processing tasks. But what's particularly interesting is that in training studies, and the ones published to date have focused on training in numerical abilities, they've found that applying this transcranial electric stimulation improved the effects of training, and those improvements were still evident 6 months later. So it seems that not only does it help make the training stick a little bit better, it seems to help it stick for longer as well. So one of the other things we're investigating is whether transcranial electric stimulation facilitates training in a typical population, and then potentially we can move that on to people with prosopagnosia. That's still very early stages though. Okay, so quick sum up. Obviously there's a lot more research to be done in this training and in this rehabilitation field. Particularly we want to do research with larger groups, we want to incorporate different techniques and see what helps which people. We also need to investigate elements of the training itself, like the duration of the training, to see whether we can maximise the benefits while minimising the burden to our participants, because it can be, quite frankly, very, very boring at times. We always do welcome feedback about how to make those training programs better. So if you have any thoughts about things that I haven't mentioned, please do feel free to highlight them.